Hold on tight, because what if you could ride an elevator all the way into space? No roaring rockets, no explosive blasts, just a smooth, steady climb from Earth into the stars. Sounds like science fiction, doesn't it? But China is racing to build this incredible space elevator by 2045, and if successful, it could redefine how humanity reaches beyond our planet. Imagine stepping into an elevator, leaving behind gravity's pull, and ascending decades faster, cheaper, and safer than rockets ever could. Picture a cable so strong and so long that it stretches 36,000 kilometers. That's nearly 400 times the height of Mount Everest, anchored firmly at Earth's equator and stretching out to a massive counterweight hanging in space. This enormous cable stays perfectly taut thanks to a cosmic tug-of-war. Earth's gravity pulls it down, while our planet's spin flings it outward. Riding robotic climbers up this cable, cargo, and even people could ascend into orbit quietly, affordably, and safely, without the noise and risk of rockets. China's space program is accelerating fast. Reusable suborbital flights are expected by 2025, heavy-lift rockets capable of over 100 tons by 2030, and making all rockets reusable by 2035. The grand vision? A fully operational space elevator by 2045, opening a new chapter in how humanity explores space. Picture the world in 2045, where commuting to orbit could become as routine as flights between cities today. The price tag is staggering, around $90 billion, about the GDP of a small country. But the real marvel is the cable. It needs to be incredibly strong, yet light. Enter carbon nanotubes, microscopic tubes, just a few atoms wide but stronger than steel, capable of carrying thousands of times their own weight. To put that in perspective, this cable would be over 40,000 times taller than the tallest building ever built, the Burj Khalifa, standing 830 meters tall. But despite their promise, manufacturing nanotubes long and pure enough for this giant cable is still a massive challenge. Experts estimate it could take 20 to 30 years of pioneering research before we can spin nanotube cables tough and light enough for a real space elevator. Right now, launching just 1 kilogram to orbit costs about $20,000, the price of a luxury car. But with a space elevator, that cost could drop to just $200 per kilogram, comparable to the cost of shipping cargo across the ocean today. Imagine what that could unlock: space hotels, factories in zero gravity, asteroid mining for precious metals, satellite networks that beam the internet across the globe, all made affordable and abundant. Picture standing on a floating platform near the equator. Instead of strapping into fireworks, you step into a sleek elevator car powered by solar panels or powerful lasers from the ground. The ride up is steady and smooth, climbing roughly 300 kilometers per hour. It might take days, but the view would be incredible, and the journey safe. At geostationary orbit, 36,000 kilometers above Earth, cargo can be unloaded directly into space or sent even farther, to the Moon, Mars, or asteroids, saving unimaginable amounts of fuel and money. But building this elevator isn't without risks. Space is cluttered with debris whizzing by at thousands of kilometers per hour, enough to slice through the cable if unprotected. Closer to Earth, harsh weather, lightning, hurricane-force winds, and storms could batter the lower parts of the cable. Yet engineers are developing self-healing materials that can close tears, robotic climbers to repair damage, and sophisticated monitoring systems to keep watch 24/7, because safety will be paramount. This ladder to the stars could launch a golden age of space exploration. Daily trips to orbit, sustainable colonies on the Moon and Mars, mining asteroids for resources, and enormous solar power stations beaming clean energy back to Earth. Space elevators could transform Earth's economy, energy systems, and expand humanity's reach into the cosmos like never before. China's space elevator sounds like something out of science fiction, but with advances in reusable rockets, carbon nanotubes, and laser-powered climbers, it is becoming a reality within our lifetime. This is more than reaching for the stars. It's about riding an elevator into humanity's future beyond Earth.